I've been asleep since day one, right?
Oh,
Usually more people like you. It's usually like 5 minutes instead of 2/3.
Yes. All right, so as you know, we're having our bonus lecture. Uh, yeah, couple of announcements. The hack challenge midpoint submission that's due tonight. Don't worry too much about it. You know, we'll just give you the points for it anyways. Just submit something. And then,
We're talking to
maybe people watch this just in case.
true.
Midnight office hours. It's going to be Thursday, December 4th from 8 to 12 p.m. 12 a.m. I'll edit that out after. And then yeah, the hack challenge final submission that's due Friday. And then the awards will be on the 8th, which is a Monday. So yeah, I guess without further ado, I'll let Zach get to it.
yeah, thank you. All right. Hi everyone. Thanks for the huge turnout today. I see every seat in the room is filled, so I know people can't see on Zoom, but it's really incredible. Yeah, so here, yeah, this is my lecture on the power of Canvas, and no, I'm not talking about the Canvas that you use to, um, see your classes. I'm talking about the composable function called Canvas that lets you draw anything. And this might seem like kind of a niche use case, right? Where you're just like, oh, I'm not gonna make a drawing app. Like, why would I ever care about this? And I want to show you like why this composable is pretty cool. So let's say that your job asks you to build a like when to meet like interface where you have to like select availability to show when you're free, and they want you to have this like drag to select multiple hours in a row, right? If you're trying to implement this with just composables, you might be like pretty challenging because you're gonna have to basically just have this like this column with a ton of boxes in it, right? And somehow like get them highlighted, and I feel like the state management would probably be like really complicated, you know? Or let's say your job asks you for this confetti animation, right? This like are you really going to make like a bunch of boxes and like try to fill them with like modifier.background in a certain way? It's going to be pretty hard. And like notice that these are two like entirely different tasks as well. What if I told you that these two very different tasks are powered by the same composable, right? So we're gonna go over like how to make these two like use cases of Canvas, and then we're gonna have like an activity at the end for you to try out the Canvas component on your own, to see what you think. So yeah, we're gonna have like first our like when to meet clone, and then we're going to look at like how a confetti animation is implemented using the Canvas, and then like yeah, a little activity to try it on your own, and I'll also be doing the activities, so we'll see how that goes. Cool. So let's take a look at our when to meet clone. So, again, like just pretend, hypothetical scenario, your new Android dev job asks you to build this component, right? So I think what we're gonna do is just start with the border because that is pretty static and we can accomplish that just like using rows and columns. And it's not going to be anything too crazy. So we'll just like go through this first as like kind of a warm up for how we're gonna like do this, right? So first we want to build this like time column, and you'll see just like general component or like component building advice is it's really nice to try to have everything as modular as possible. So we're starting off with just like the time column as its own composable, and that will make it so the final like grid composable is just easier to read. Yeah, and we're just starting with like this column that's going to fill the whole height of the screen. And then inside of this column, we're going to basically have like a bunch of text. And notice that I'm actually not using lazy column. And I think something that I see a lot of like beginner Android developers do is like overusing lazy column. In my opinion, like lazy column should really only be used for when you have like a list of items and you don't know the size of the list and you need to show all of those items. But like really the performance of column is going to be good enough for like most tasks, and it just makes the code simpler instead of having to write out like items and stuff. You can just like use it directly as a composable. And you'll notice this like grid height over 2. So what this grid height is it's like the number of cells that are in each column. And if you look closely at our like demo here, you can see that some of the cells actually take up only half of an hour. So we have to like account for that in our implementation, which is why we have like grid height is like the full height of the grid, and we're only going every hour, so we go like grid height over 2. And then there's this like helper function, get time for row, that basically given an index, it returns like a time based on the starting time of the when to meet composable. And then yeah, we just like use a standard date formatter and we like style the text, right? So that should be like relatively straightforward. And then at the very end we have a spacer, and you can see that we're actually using weights to get the correct spacing. So like we want basically each text to like occupy like 2 grid cells, and then we want to leave like half of a cell left over. That's what this -1 is here is for. We leave half of a cell left over for the spacer at the end, which takes up like half an hour basically. So that's kind of the idea of the time column. And there's probably other ways to build this without using weights. That's just the approach that I went with. And then there's the date row. So the date row is like this row right here. So this is actually going to be even more straightforward. Um, Basically, like we're going to take in a list of dates, and we're just going to display each date in a column using the date formatter library. So this library is like using datetime formatter of pattern, super useful way to format dates, something you'll have to do all the time when you're a front-end developer. So just like that's pretty cool to keep in mind. And yeah, and then like to get the spacing correct, we're just using like alignment and arrangement, stuff you can all see on the documentation. So there's our date row. And then we put it together, and we can see how easy this component is to read now that we've done this like modularity, right? So we just have a column, and we put our date row up top, and then we have a small space, and then we have our row and a time column. And then the next thing in the row is the content, which is this grid content area right here. So that's pretty much like the container for the availability grid. We haven't used the canvas quite yet, but just like warming up, building some UI. Yeah, anyone have like any questions about anything they've seen so far? And there's there's only a couple people, so we have a lot of individual help. Yes. Oh yeah. Oh yeah, yeah. Sorry, I didn't really go into that too in depth. That's a good question. So dot weight, basically, you can think of it as it like defines the rate at which a composable like scales relative to other composables, which is like kind of unintuitive, but I think it's like the best way to explain, like to accurately explain it. So let's say that we have like our layout is like this box here, right? And I put a component, or let's just say this is a row, and I put a component in here that has like a weight 0.3, and then I put another component that has a weight of 0.7, right? What would happen is like these two composables, you can think of it as like this one is going to grow at like a rate. It's going like all composables with weight will grow to like fill the available space, right? But like they grow with like different weights. So this like composable that has a higher weight would basically grow like faster to take up like 70% of the area, and this one would only take up like 30%, because of those like different growth rates, sort of. So that's kind of how you can think of it, because it's not exactly like analogous. I mean, I guess you could just say it will take up like 70% of the box, but then the thing is like that simplification kind of breaks down, because like you could have something like this. I don't know if I'm sorry if I'm not writing large enough, but basically like each of these are 0.7, and like this would still work. This would be valid code, and like it wouldn't like crash or anything like that. Even though this doesn't add up to 100. So that's why it's like the simplification of just saying like, oh, these are percents of the parent layout size is like technically not correct. So I think it's like easiest to think of it as like the rate of growth of those composables like within the size. So yeah, I think 0.8. I don't remember exactly where I got that number, but I'm pretty sure that like it probably has to do with just of um the number of like grid cells, and having them like grow at rates relative to each other. Yeah, does that make sense?
Yeah.
Okay, cool. Yeah, that's a really good question. I think weight can be like pretty confusing at first. Any other questions?
How did you get the formula of like divide by 2f minus?
Oh yeah, yeah, okay. I think this took like trial and error. I mean, it's been a while since we implemented the component. So let's see. Yeah, okay. So basically this column, this was for the time column, right? And I think the idea for this was that, wait, if we look at like the final product here, oh, okay, the ending of it is cut off. Um, but like basically, I think the idea is that we wanted it to span, like we wanted the weight to span based on, okay, sorry. So we want each text to take up like 1 full hour block, right? And we have like grid height over 2 text. So uh yeah, so we have grid height over 2 texts. And when we have this weight be grid height over 2 - 1, it basically makes it so the column like fill is like as tall as the number of hour blocks. Yeah, the number of hour blocks in the grid, which is grid height over 2, and then minus half of an hour. And I think like the minus half hour is because like we want to put a, yeah, I'm pretty sure we wanted to put a spacer at the end. Um, but also like don't get too caught up in like the specific formulas. Like I think like weight, I don't like if I re-implemented this today from scratch, I don't know if I'd necessarily choose weights for this. But I think just like at least knowing what the weight modifier does and how you can use it is pretty important. Yeah, does that sort of answer your question? Okay. Anything else? Okay. So now we're gonna get into like the actual Canvas part of this. So yeah, we can even just like read the actual composed documentation for what this is. Allows you to specify an area on the screen and perform canvas drawing on this area, and you have to specify the size with a modifier, which is, yeah, that's another important part of Canvas. So the other thing is that like when you're in a canvas, you'll see that it has this parameter called onDraw, which takes a function in draw scope that like returns nothing as a parameter. And this draw scope provides us two different action, like different functions that allow us to draw different things on our canvas. So we have like draw rect, draw circle, draw arc, and this will just allow us to render shapes in arbitrary positions on the phone screen. And that basically means that we can build anything we want. Like you could build all of Material UI like from scratch in Canvas if you wanted to, you know? So it's a very powerful component and it's like pretty low level as well. There's also a modifier that's like tends to be used a lot with Canvas called pointer input. And that's going to be helpful for this like one to meet task, which we're going to see in a second. It's technically not related to Canvas, but it's often used with it. So yeah, let's see how we're going to like take input here. So basically when you use like modifier.pointer input, you're going to receive this event. Let me see if I can do a laser pointer. Yeah, okay. So you're gonna receive like this event. And there's different types of events based on like what happens to the pointer. So there's this like press event, move, and release. And I'm pretty sure there's like more of them, but those are the three that I'm gonna use for this like one-to-me implementation. And basically we just want to use this to modify state, right? Remember that Jetpack Compose is all about like stateful UI. So really like when we take input, we should modify a state and then have our UI react to it. So what do we actually need to track when we're like looking at this one-to-me component? So we need to figure out like where did our grid selection start, right? Like what is the grid cell that we started tapping in? What is the grid cell that we end in? Or like yeah, what is the grid cell that we end in? And then another question is like when are we removing from the grid? And I wanted to make this grid like really simple. Um, so basically the actual representation for the grid is a 2D array of Booleans. And it's true if the grid cell is filled in and it's false otherwise. So this allows like the implementation to be a lot simpler. Because like we are removing from our grid if we start pressing on a grid cell that's already filled in. So if you remembered from the demo video, the way that you erase from the grid is if there's a grid cell that's already filled in and you start dragging on it, then you are in like the erasing mode. And otherwise you are not. So that is like this is removing thing. The other thing you'll notice is that we actually like we don't get these like row and columns, this like grid cell for free. We have to do like a coordinate conversion, which is just from this get grid cell method. And basically we're given an offset, which is like a pair of x and y that like our that we pressed on the composable, like relative to the composable's origin. Um, yeah. So then like I just like made a helper function to like make that easier for myself. And the code isn't there, but like really or it's not like in the slides, but it's just like pretty simple like division based on like the cell size in pixels. Um yeah. And then if we move, so this is our next event. Like if the person moved their finger, they're already holding it down, but the new event is that they moved. All we have to do is change the selection, like the ending selection grid cell, and update that to be where their finger is right now. Because the start is never going to change. That's just where they started the drag. Right? And then our final event type is release. So in that case, we have to actually update the grid. And basically, like what this function does is it will, like, based on the selection start and selection end state, it will change the grid by the selection, and then we pass in like whether we are currently removing or adding grid cells. And what this does is it just looks at the selection start and end and just like does a loop over the grid cells that are in those bounds and basically flips those like Boolean values. Um, yeah, and then we have to also like reset our selection when we release. So we say, okay, we're not removing grid cells anymore. The start and the end are now null because nothing is being selected. So that's a little bit about input. And then we actually have to like render that input. And I think this is going to be like simpler than you might think. Because Canvas has like a lot of really great resources for, rendering stuff like this. So what we do is we just do a like double for loop over our grid. So first we look at like the indices for the rows, and we're filtering for even indices here. Because remember, like even though there's two 30-minute like blocks inside here, we don't want to show the border twice. We actually just want to show the border every hour, right? Um, so that's why we have this like filter. And then we just look inside each row's indices and we look at like the column within each row. And then we just get our position just through like simple multiplication. Like we know how large each grid cell is, so we're just going to like offset the position based on that width and height. And then all we have to do is call draw rect and just pass in our styles. So what's cool is that Canvas has like a bunch of different styles for rectangles. Stroke is one of them. And stroke basically just means we're only going to draw the border of the rectangle. And we can pass in a certain color, right? We just calculated our top left. And then the size as well is just going to be the rect width and the rect height times 2. Because again, we're including like two 30-minute blocks in every hour. So that's the border. And then the selection preview is a little bit more complicated. But like again, with this like sort of minimal like representation of just all we know is the start of the selection and the end, we're actually going to be able to draw this like full selection preview. And the way that this works is we need to, based on the start and end, we need to find the minimum and maximum row and the minimum and maximum column, right? And yeah, so the reason for this, we're basically just finding like the top left and bottom right, I believe. Oh wait, actually, no, sorry. Yeah, the min row is just like is basically just going to be like whatever the highest point is, right? The min column is going to be the leftmost, the max column is going to be the rightmost, and we can like use this to figure out a position of our rectangle because we're trying to figure out the bottom left of our rectangle. Um, and the bottom left of that rectangle is going to be at the minimum column, which is the leftmost column, and then also, yeah, I think it's bottom left. Yeah, the minimum row. Actually, okay, I think. Oh yeah, oh yeah, top left actually. Okay, my bad. Yeah, so I forgot like when you like pass in arguments to draw rect. Like I think you can probably pass in top left or bottom left. So I think I chose to pass in like the top left of the rectangle, and that makes sense. Like the way we get the top left of the rectangle is from the minimum column, that's the leftmost, and then the minimum row is actually the topmost row. Because oops, rows in decrease as we move, sorry, rows increase as we move down here. Um, yeah. And then we also see like the size is like more kind of interesting calculations, but really like the maximum column minus the minimum column, that is just like the width of our selection. And then we have to do like plus one. And like the reason the plus one is here is like if you think about it, if like the minimum column and the maximum column are the same, we should still like select that column. It shouldn't just be zero. So we just like add one. And very similar for the rows and like multiply by the rectangle height. And then the cool thing here is there's this like I made like a util function called change brightness, which basically just allows you to change the brightness of a certain color. And that was used to essentially make this like a brighter purple. And you might think like, oh, just like turn down the opacity. But then the issue with that is when you have purple here and you try to draw over it, it's not actually going to make it lighter because it's just going to be like more see-through. So it'll just like look the same kind of. So yeah, you have to like change the brightness here. And then also the other really cool thing is the stroke, right? We can even specify a path effect. So these dashes, like this might seem like something really complicated to implement, but actually it's already like in there for us. The canvas like offers us that customizability. So we just have this like dash path effect. And these intervals, like I kind of forget what that means, but it's just like tuning values from trial and error. You can like look up on the documentation what the intervals are, but I'm pretty sure it just defines like the width of each dash and how far apart they are. Um, yeah, so that's like one of our rectangle is just the stroke, which is this dash border. And then we also draw the actual main rectangle, which we use in like the fill state. So yeah, I think we actually did have it. Oh right, yeah. So we made it so the dashes are darker than the normal purple, but the fill is lighter than normal purple by like changing this brightness, and then we also like decrease the opacity so it's like on top of it. Yeah. So that's our like draw selection preview. And then drawing the selected grid cells is actually like much simpler than that, right? We have our grid, which again is this 2D array of booleans, and we iterate through the grid. And since it's a boolean, we can just say, oh, okay, if this grid cell is filled in, we get the position as we're used to doing, and then we draw the rectangle uh like where it needs to be with the fill color. So yeah.
So why is a good list of
Oh yeah, I just thought like okay, when I implemented this, I was thinking it's basically just a simple representation of like whether a grid cell is filled in or not. And it's like really general as well. So even though this is like actually dates under the hood, it's like imagine if you had a a list of dates and like each date was you use that to figure out whether it's filled in. I think it's like a lot less intuitive to work with than just like booleans. And it's like very simple, like, oh, when you fill in, right, you just set it to true. When it's not filled in, you set it to false. Does that make sense?
Yeah, so what would you use a Boolean array for this?
Oh, that's what you meant. Okay. Yeah, yeah. So I think I chose Boolean array here because like let me think about this. I think the reason is that we know well, okay, so there is no such thing as like a 2D or okay, I guess you could use like the primitive Boolean array, like the Java Boolean array if you wanted to do like a 2D array of Booleans in Kotlin. But like there isn't a Kotlin 2D Boolean array,
Oh,
right?
you just wanted to
So
do that same.
yeah. So basically like just using a Boolean array, it's like, oh, it's like more efficient, right? But like beyond but that doesn't matter at all. I just also thought that like because we know the size, it's like why not use the array? You know, you don't have to. You could definitely just do a list of Booleans, but yeah, I guess I just sort of thought that like since we can use it, why not? And it's no more complex than a regular list. So, yeah. And it's also that like fixed size as well. You get like more guarantees, I guess. Um, yeah. So That's all, right? We've implemented a fully like custom when to meet availability component. I am simplifying things a little bit. Like I'm skipping over the code to how do we convert this 2D array of booleans to a list of dates. But like I promise you it's really not too complicated. It's just using like some basic math with like multiplication based on the indices of the grid. And I think like the main like moral of the story here, I guess sort of like developer tip, is I think you should try to only use external dependencies from like big companies that are guaranteed to support them for like the tasks that you really just cannot complete on your own. Like I think for a lot of beginner Android developers, if they're tasked with like building this one to meet interface, they might look up like, oh, like one to meet library, but like oftentimes that interface is probably gonna give you a bunch of headaches because it's like it's not going to be to your specific needs. And also it could end up like losing support later on, which would mean you'd have to like either modify the existing code, which you didn't write, and that's going to be pretty hard, or just like rebuild it from scratch anyway. So just like general wisdom, like I just think it's really nice to try to build these things out on your own, and you'll find that they're actually not as complicated as they might seem. Um, yeah, so any questions about any of that? I know I went through that kind of fast. Yeah.
Yeah. One of the very first slides before the other stop question, just like had something like row to column. Yeah.
Oh, yes. Yeah, so that's creating a pair. So selection start and selection end, they're both the type pair of int, comma int. And two is just like an infix operator in Kotlin that creates a pair based on the left and right hand side of the operator. Yeah, good question. Any other questions? Yeah.
What is draw scope?
Yeah. So yeah, in Kotlin, scopes are like basically they basically let you write a function as if you are in a certain class. So let's say that like let me try to think of a good example of this. Um, so lazy columns actually have a scope. That's called a lazy list scope. And like when you're inside a lazy column, you can't call composables directly inside of it. You have to call like item first, right? And that is like one example of a scope where it's basically like enforcing that when you're in the scope, like you can only like you can't call composables, you have to like call items, and we have these like built-in functions for you. So like draw scope is a really similar idea. It's basically saying like, hey, you're in a canvas. You can't just like call composables here, but what you can do is call these different methods such as draw rect, and we're going to get into later like other types of methods too, but basically like drawing methods. Does that sort of make sense? Okay, cool. Yeah, any other questions?
Is this an extension function? Or...
Yes, that good. Yes, you have a good eye. So draw scope dot draw selection preview. This is an extension function. And the reason that like I made this as an extension function is because we're required, if you remember like the type of this composable parameter, right? It takes a function in draw scope that returns nothing. So if we want to call functions in onDraw, they have to be written in draw scope. So it's like an extension function. It's basically, and if you remember like extension functions, right? They let us write functions as if we're writing them as a member of the class. And when we're a member of the class, we have access to all of the class's methods. So drawScope has all of these methods like drawRect, right? That we have access to. And yeah, we're taking this like extension function on drawScope as a parameter. So yeah, good questions. Very good questions today. Any more? Okay, cool. Yeah, so then we're gonna move on. Let's see what time it is. Okay. It's actually taking me longer than I thought. Okay, but we're gonna move on to the confetti animation. This is another really cool one. So if we're gonna start by just like defining some UI state. Oh, also wanted to give credit to Melissa on our Android team. She implemented this, and I'm stealing her code for educational purposes. So yeah, we're gonna start by defining the UI state. And the way that we do that is like we're basically just going to make this helper class that'll make things like way easier for us, which defines a confetti particle. And it's going to have information about the particle because the way that we're going to actually do this confetti animation is through a mini physics simulation, which like Canvas will actually allow you to do really easily, which is super cool. So yeah, it just has like a start position, right? It has an X velocity, a Y velocity. It could have like a size, a color, and then a certain shape, which we like defined. I think she might have defined this as an enum, if I remember correctly. And then there's also a rotation. And this will make it easier for us to basically just have a list of particles that we can iterate through and draw. Yeah, and then we actually have to assemble the list. Hopefully that's not too small for people to read. Um, but what's pretty cool is like we have this list of particles and we use remember. So on it's not like recreated on every recomposition. And the key that we use for remember is this like UI state dot showing. So if we're showing the particles, then like whenever we show the particles, this means that the list will regenerate, which is pretty cool. And we have this list based on our particle count size. And then each member of the list is created by this function. So yeah, we basically just get the X and Y by spawning like randomly within inside this these like rectangular bounds, which is just done by using like random.nextFloat. And this rectangular bounds is like the bounds of the confetti. And we have our offset, we have like a random starting angle, a random speed, and like and then some velocity components based on that speed. So, yeah, your physics knowledge, hopefully helping you out here. And then we also have this like size in pixels, which is again just random. We just want a bunch of random particles. And then we have this list of starting particles. Even the shape is random, done down here. Yeah. So once we have this list, we now have to actually show the animation. So the way that we're gonna do that is using like animate float as state. So basically we're gonna have this this is our progress of the animation, and what it does is it uses a tween. So this is actually like something that you see a lot in all types of front-end development for animations. And also in game dev, like I use this a ton. So tweens are basically like it's basically a way to get from one value to another value using a specific easing function. What an easing function does is it like defines how quickly you're going to get to that value. And I feel like, sorry, that's not a good explanation, but what is better is if I like draw it out for you. So a linear easing function is just a straight line. So like this is like y equals 1, and this is x equals 1. So that linear easing function just says that, right, like as we, let's see. Yeah, so our target value is 1, and we're going from 0 to 1. And we're basically saying that we're going to go from x equals 0 to x equals 1, like linearly as time increases. And this contrasts with like an exponential function. So let's say my function looked like this, right? So here's y equals 1, here's x equals 1, right? And this is like 0, 0, right? So the idea is that x is basically always going to move at a constant rate, but then the progress here would not be constant because of this easing function is like non-linear. So x is going to be moving at a linear rate from 0 to 1 over 1200 milliseconds, no matter what you choose. But y, which is actually what is going to be read as the progress, like that is going to change based on the easing function that we choose. So the reason we choose like a linear easing function for this is because that we want our progress to move like directly with time because we're doing like a physics simulation. So we just want it to move linearly as time increases. Yeah, but like the reason I talk about easing functions is you have like customizability over what easing function you choose, and for other animations, stuff can be like really cool when you choose different easing functions. So No, it's like a cool thing to keep in mind. Yeah. And then we also define our gravity and then our time. So if you remember, our progress moved from 0 to 1. So in this implementation, we said that time was just progress times 1.2 because our duration is like 1200 milliseconds or 1.2 seconds. So yeah, and then we get our position at our time by just like solving a basic like equation here. So position is the start position plus the velocity times the amount of time that has passed. And then the y position is okay, so we have velocity times time plus F equals yeah, F equals ma, we have like our acceleration here, gravity, and yeah, it just works, physics. So yeah. And then we also have our gradient brush. So this is another like super cool part of Canvas is that you can define like a brush as the way that you're going to draw something. And this brush will give you control like a ton of control over what colors it uses. So we can actually use a linear gradient to make the confetti kind of pop. Instead of just being like solid colors, we can have it go through this gradient and just look like much prettier. Um, yeah, and then yeah, I guess we also let's see what it okay. Yeah, I guess we also have like a start and end for the gradient. I think that's basically just like defining yeah, it's just defining like where the actual linear gradient starts and ends. So like I guess the confetti might be like this big, but then the gradient is like in this portion in this example. So yeah, and then our rendering is actually going to be pretty simple. So now we're in the draw scope and we're just like iterating over our list of particles. And we just like switch based on the particles, or I guess sorry, when statement. I've been writing Java recently. When statement based on the particle shape. So we have a circle and then okay, well, we're just gonna draw a circle based on the size, the offset, and the brush, and then we have a rectangle. This is actually going to be a little bit different because we can use this like rotation, which is pretty cool. And this just allows us to rotate the particle and give us that kind of like rotated confetti look. And then we also have our draw round rect, which gives us the rounded corners on the confetti as well. So yeah, and then yeah, that all comes together to create the animation that we saw here, which I will put on the screen as I ask if there are any questions. Yeah.
Were the numbers just like randomly chose, like for gravity and
Yeah, so those numbers are just basically chosen by experimentation usually. So you would just like try a like completely random number, right? You might start with 1. If it's like really slow, then you would like increase it. If it's really fast, you decrease it, and you kind of just like do a little search for what makes it feel right. That's like practically how those numbers are chosen, yeah. Any other questions?
When does it stop rendering?
Oh yeah. Let's see. That might have been like omitted from the code, but yeah, the basic idea is let's see, where did we get our positions? Oh wait, this is the let's see. Yeah. Yeah, so oh right. So I think this was actually all still like in the draw called the canvas, like getting these positions. And when we stop rendering, this is actually a part of like a more complicated like singleton component. Which like yeah, if you're just like taking the course, you might not be like too familiar with that. But basically the idea is that we wanted to be able to use this animation wherever we are in the so we had this like UI be placed at the root of the app, and we have this like UI state dot showing, which basically just shows whether we are showing this composable or not. And I remember like at the beginning of the composable, there is like a check to just see like, oh, if we're not showing this composable, then we just return. Um, and the idea is like this UI state dot showing we basically like have a system set up so we can modify this value no matter where we are in the app to like choose whether or not the confetti shows. And if we hit this if statement, which like is not depicted in the slides, but if we hit that if statement, it will just stop the canvas from rendering entirely. Does that make sense? Okay.
You said it's represented by symbols.
Uh, well, so the composable itself is not a singleton. It's just that like we have a we do have a singleton that stores the state of whether the confetti is showing. And then we can update that singleton like in our view model. So yeah, this is like model view model, right? I guess like this is basically the idea for people like taking the course, right? The idea is that this is backed by model view model. So there is a model that just holds the state of whether this confetti is showing. And models are singletons. You can access them from anywhere in the app. So the view models can inject the model and then change this UI state.showing to be true or false. And then the other thing is that this composable, we place it like at the root of our app, maybe like next to our navigation, like at the very root of our app. And that allows us to, and then like at that root of the app, we also consume that model and we watch its state. And then based on that state, we choose whether to show the composable or not. Yeah, did you have any other questions or? Okay, cool. Yeah, any other questions?
So this every time you click the ready button, it'll be like different because it's using a camera.
Yeah, exactly. Yeah. Yeah, that's the nice thing about using random. It will be different, which is cool. It'd be hard to like you don't want to hard code all of those values. And it lets you like have this particle count. This can really be anything you want to, which is really cool. Any other questions? Okay. We don't really have too much time for the activity, but you can try it. So oh yeah, there's Phil Blackner. Android development YouTuber who just made a video on the canvas, which I thought was funny. But yeah, try it yourself. So you can just try like using the canvas composable to create like a basic drawing app. Um, Make it, yeah, and you can just like make it so the user can draw squiggles on the canvas and like try using that like pointer input modifier. It's a lot to ask for like 7 minutes, I think. But you know, maybe if you're bored at home and you want to try doing some Android stuff, you can try it out. Um, yeah, I don't think 7 minutes is too much, but I guess we can also talk about like a pretty interesting question, which is like, how do you think we'd represent the state for this, right? Because if you remember, like compose is all based off of state. We want to use pointer input to modify state and then have the canvas like draw that state. So if we want to be able to draw lines, like how do you all think we could like represent that in like state using Kotlin types? Yeah.
The dumb way is a bunch of start and end points.
Yeah, no, that works totally fine. Yeah, so I think yeah, but like what I was initially thinking is like you just basically you would have like a list of like pairs of or yeah, I guess it would be like a list of like pairs of floats or something, and that would just be like the coordinates that the person like moved their finger on. And then at each of those coordinates, you just draw like a really small like circle or something like that, right? Yeah, so basically what you're saying like right? And that would be a very, very naive approach because if you're holding down, like imagine I'm holding my finger here and I'm just every single frame I'm adding a point to that list, right? So that's where like your idea comes in of like the start and end points, you know? Um, and like yeah, that would probably be like an even better approach for sure. And then if you wanted to like optimize it even further, right? We have that list of start and end points and we say, okay, we're only gonna add to this list if like the finger has moved far enough away. And now we're actually getting into like something that is really reasonable and could actually be inline in an app and not take up like too much memory, you know? So yeah, all considerations to go with. And I'm sure there's like tons of other ways to represent the state here that you can think about. Like, what if you want to add an undo button to the Straw app, right? That's a whole nother layer of complexity. And this is actually the kind of thing that you would see in like industry Android interviews. Like hard industry Android interviews. Don't like not this kind of thing for like new grad, but I have heard of companies like asking like this type of drawing question, so interesting to think about, interesting to try at home. Um, yeah. Anyone want to like discuss any more about this, or if not, you can like feel free to go early if you want to. I can stick around and try to make this, I guess, but yeah, I think that's gonna be it. Yeah. Thanks for the huge turnout. Thank you too for coming though. I appreciate it. Yeah. Hope you all enjoyed and learned something.
You have to rate this course.
Do we only scan this for uplift or do we have it in the other platform?
Yeah, so the when to meet clone that I showed